Hello everyone. We've already covered CDNs, we've covered proxies, reverse proxies. In this video, we'll be studying a related concept, which is API gateways. So the idea is that we already know about reverse proxies from the previous video. API gateways can be considered a specialized version of reverse proxies. So what does a particular flow over here look like? Very similar to what we discussed previously. This is your device, client device or mobile phone, let's say. This will make an API call to a API gateway, not the server directly, but the API gateway, which will then decide where the request needs to go to. This is not server, this is service one, which could have its own servers. Same for service two. It has two servers, service 3 has three servers. Very random architecture I have over here. Don't dig too much into this, but this is what the overall architecture looks like from a very high level, which has been drawn like a child's drawing. So question is, why do we need API gateways? We already know that API gateways are like reverse proxies. So the needs are somewhat similar to what we studied when we were talking about reverse proxies. One of the very important points handled by gateways is your authentication. Let's call it auth n. All right, so you have your authentication plus some restrictions that you may want to enforce on your services. For example, this could be a geographical restriction. Like if again you have a website like TikTok, which is supposed to be banned in India, if the request seems to be coming from India, the IP address seems like it's from India, I want to restrict that. This could be a time-based restriction that I don't want my website accessible from 11:45 to 12:15 a.m., which is I think what IRCTC does, something like that. I'm not saying that they use API gateways. I'm saying that this is something that you can use via API gateways, this sort of functionality. Or even for maintenance, like if you want to shut your websites off, if you want to remove access completely from your servers, you can use your API gateway as a circuit breaker. Focus on this phrase circuit breaker for that, because what it's doing is that it is cutting off access to your servers. So this can be useful for maintenance. It can even be useful for a case where, let's say, somebody's trying to attack your websites, your servers specifically. And the best way to handle it is to cut the attackers off, reduce the blast radius. So what you do is you just cut it off and say that you can't access anything anymore because my entry point does not exist for you. All right. So that is one way of handling this. Then there is rate limiting. API gateways can also handle rate limiting for us. So let's say you're a user, you're making a request to fetch a certain image. And I said, no, you can only access this image 3 times in a certain day. That can be implemented using your API gateway. It can also be implemented on your server. It can be a part of your server side logic, but it can also be handled over here, especially if it is some global handling, some generic handling that you want to achieve. Then you can also have your load balancing handled via your API gateway, especially if your gateway is managing a single service which has multiple servers horizontally scaled. If you don't know what horizontally scaled means, I suggest you watch lecture 1 of this particular series, in which I explain what it is in fine detail. So we have load balancers over here, and basically API gateways can determine which server should the request go to in a very smart fashion. It could be round robin, it could be based on the traffic that we actually have over here. And speaking of traffic, we can actually use this for analytics as well. This API gateway can be used for analytics. So how can it be used for analytics? It can be used to store traffic patterns, because if all requests are coming through your API gateway, it is the best source of truth for determining what traffic patterns are, which service is receiving how many requests, which particular path inside a service is receiving how many requests, what is the average time that a request is taking, because when you send a request, the API gateway will also receive the response and then forward it back to the user, right? So we can use that to judge traffic patterns for determining SLOs of our services. All right, so that can be used for analytics. We can also have logging in place, like every request should be logged, which user made the request, where did the request go to, at what time was this request made, all of this. And it could also be used for API usage purposes. If you want to track it, basically, API usage tracking plus billing. So if you have a SaaS based product like OpenAI, which tracks how many tokens does each request have and how many tokens have been allocated to each user, something like that, or any API that you generally consume, it has a certain quota. So an API gateway can track that very easily. And this user has made a request so many times, and so they can cut you off, basically have either rate limiting or control your billing using this tracking mechanism. So if I had to paint a picture for you on how this flow takes place inside an API gateway, you already know the features, and you'll be able to make the connection yourself as well. But just to put it out there for you on my screen, what happens is that you would first make the request. All right, let's say this is an HTTP request. Any other protocol, it may work the same way. All right, you have your request. The request will reach your API gateway. What it will do is that it will validate said request. And by validate, I don't necessarily mean validate exactly how it should be. Like if I'm entering an email and a password, it will check the email if it is valid. It will check the password if it is valid. Not exactly that. That is usually handled at the service level. Validate the request means if the route that is being processed is valid or not, if the service that we are trying to reach over here is valid or not. So it tries to validate the request, otherwise it may return 404 not found. All right, so that has been validated. And then what ends up happening is we may check if this IP that this particular request is coming from, if it is blacklisted or not. So it could be in your deny list or a blacklist, or it could be in your allow list. Then comes the identity check. Now basic parameters have been verified. Now we want to ensure that you are eligible to make this request or not. So an identity check is needed over here, which will first authenticate you, and then it may also authorize you. All right, this can be handled at service level, but it can also be handled at the gateway level for certain global applications. All right, so we have this over here, and once we ensure that you are the right person to make this API call, we will check rate limiting. We will check your rate limits, that okay, you are the right user to make this call, but have you already called me enough times? If you have, I will return my status code as 429, I think it was, which was for too many requests. Otherwise, I will send your request further down the chain. Further down the chain, what happens is what I would like to call route based redirection. So, if you have a platform which does a variety of things, if a user makes a request on slash content, now this is something, of course, that you will configure when you set your gateway up. It doesn't happen automatically exactly, but yeah, slash content could redirect to the content service slash user. Any request to slash user, let's say a login request or a logout request, comes to your user service. Any request which has the path starting from slash cart goes to your shopping service, something like that. All right, so route based redirection then sends your request to the relevant service, and this happens. Your request is then processed, and your response is then returned if everything is okay. If everything is not okay, then we may want to set up some error handling as well. Now you could do this at gateway level. You could do this by integrating a third party somewhere. But something like, let's say, if there are too many errors on a certain service, you could have an email sent to the developer saying that there are too many errors, check what is happening. Maybe it could be an attack, maybe it could be something else. Maybe your traffic, maybe your service is just not able to handle a lot of traffic. All right, so that is something you can do. You can also handle logging at this particular level once the response has been sorted out. So you can log that and you can connect it maybe to a monitoring service, which can then take take the request data from you and log it, calculate it, do some analytics, form some dashboards and the like. But yeah, at gateway level, this is sufficient enough. And this is roughly what an API gateway does. It is used to essentially protect your servers from the rest of the internet. It is used to handle traffic via load balancers, via rate limiting, via circuit breakers, and it is also used to redirect flows within your network, private network, which has your gateway and your services. Alright, so that's basically it for API gateways. In the next video, I will talk about another cool concept, so stay tuned and follow for more.